Hello, and welcome to Things Explained. This lesson is on mathematics, how to add and subtract fractions. Let's begin. It's time to become experts at adding and subtracting fractions. Before we move on with examples, I will be introducing a few terms and defining them for you. Let's waste no time. The first term here is the numerator. The numerator, in green, is the number in a fraction that goes above the line. The numerator is divided by the denominator. The denominator, in red, is the number in a fraction that goes below the line. The denominator divides the numerator. Just so we've made it clear, numerator, top, green. Denominator, bottom, red. Great. Now let's move on to some rules. Adding and subtracting fractions. In order to add and subtract fractions, they have to have the same denominator. When fractions are added or subtracted from each other, you only add or subtract the numerator. The denominator does not change. This is because the denominator is the context to the size of the ratio. When adding or subtracting fractions, if you add or subtract the bottom numbers, you are not doing it right, only add or subtract the top. Here is an example of adding two different fractions, with the same denominators. 45 over 37 plus 61 over 37. Remember, equal denominators is a requirement before you can add or subtract. 45 over 37 plus 61 over 37 is equal to 106 over 37. Let's move on. Here is another example of adding. 151 over 109 plus 152 over 109. Can you figure it out? The answer is 303 over 109. Adding fractions with the same denominator isn't too hard, is it? Of course, I'm not going to leave you stranded here. We are going to explore every situation with fractions. Let's move on to simple subtraction. Subtracting fractions is similar to adding fractions. As long as the denominators are equal, you can subtract fractions from each other. Remember, you only subtract the numerators. Here's an example of subtraction of fractions with the same denominator. Example 1. 121 over 45 minus 34 over 45. When subtracting fractions, we apply the same rules as when adding fractions. Are the denominators the same? Check. Now, proceed with subtraction, but only subtract the numerators. The answer is 87 over 45. Next example. Example number 2. 50 over 12 minus 150 over 12. Can you do it? The answer is negative 100 over 12. You're getting pretty good. So I've decided to throw a curveball into the mix. We're going to go a little bit advanced, but this step is necessary. So what if you wanted to add fractions, but they had different denominators? When you are dealing with two different fractions of different denominators, you cannot proceed with adding or subtracting the fractions until both denominators match. Allow me to walk you through this problem, and the solution to it. Let's say you had these two fractions, and wanted to add them. 132 over 57 plus 24 over 68. In order to add them, you would have to make their context the same. You would have to get one of the denominators to match the other. When choosing which denominator to change, it's always cleaner to change the smaller denominator into the larger denominator. So we're going to be transforming the 57 into a 68. But first, let me slide this problem a little bit towards the top of the screen. We will use algebra to turn the 57 into a 68. In order to do this, we have to find out what number to multiply 57 by in order to make it a 68. The mathematical procedure is as follows. 57 times what is equal to 68. We need to isolate the unknown variable, the question mark. This question mark represents the number that we need to multiply 57 by in order to make it into a 68. So we start by dividing both sides of the equation by 57. The division operation cancels out the multiplication operation of times 57, leaving the question mark on its own. So now we have question mark is equal to 68 over 57. If we perform the operation, dividing 68 by 57, we can find the question mark, which represents the number we need to make a 57 into a 68. So, 68 divided by 57 question mark equals 1.193. Let me move that out of the way for you. So what we have here means that the number 1.193 is the number that you need to multiply the fraction 132 over 57 by in order to make its denominator equal 68. This must be done before you can add both fractions. When converting the fraction 132 over 57 to a denominator of 68, it's important to multiply both the numerator and the denominator of the fraction 132 over 57 by the number necessary to change the denominator to 68. So let's get to it. We're going to convert the first fraction into a form which has a denominator of 68, so that we can finally add these fractions together. So the first thing you do is times 132 by 1.193, which gives us the new numerator, 157.48. Now, times 57 by 1.193 to get the new denominator of 68. And there you have it. The problem is half done. 157.48 over 68 is our new converted fraction. We don't need that other guy anymore. So now your problem becomes 157.48 over 68 plus 24 over 68 is equal to what? The denominators are now the same, so we can finally proceed with adding the fractions. And the answer is equal to 181.48 over 68. Well, that was a headache. Let's explain a little bit of why this method works. Now the reason this works is because fractions are ratios. For example, if you take the fraction of 132 over 57 and treat it as an operation, 132 divided by 57 is equal to 2.3159 over 1. The fraction 132 over 57 condenses into a ratio of 2.3159 to 1. If you take the fraction 132 over 57 after multiplying it by 1.193 to make its denominator 68, you get the fraction 157.48 over 68. If you treat the fraction 157.48 over 68 as an operation, something interesting happens. 157.48 divided by 68 is equal to 2.3159 over 1. As you can see, multiplying both the numerator and denominator of a fraction by the same number, in order to get the denominator to be compatible with another fraction, does not change the ratio of that fraction. This is why we use this method to convert the denominator into like terms when we are seeking to add or subtract fractions with unlike denominators. The denominator is just the context for the ratio. Before we tie up loose ends, let's put together everything we learned so far. I will leave you with one more example. Make sure to put together everything you learned. Before you can add or subtract fractions, the denominators must be the same. You do this by finding out what number to multiply with the numerator and denominator of one fraction, to make its denominator the same as the other fraction. Then you must add or subtract only the numerators. Here's the last example. Are you ready? 117 over 115 minus 90 over 80 equals what? Please pause the video and try it for yourself before continuing. So, the first thing we want to do is make the denominators the same. We'll start by raising 80 to 115. Find out what number to multiply 90 and 80 by, in order to make the 80 into a 115. So in order to do this, we have to ask ourselves, 80 times what is equal to 115? Using algebra, we have to isolate the unknown variable, the question mark. To do this, divide both sides by 80. This cancels out the times 80 on the left side of the equation, and leaves you with question mark is equal to 115 over 80. Divide, and you get question mark is equal to 1.4375. Armed with this knowledge, let's go back to our problem. So we found out that you have to multiply 90 and 80 by 1.4375 in order to bring the denominator of 80 up to 115, so the fractions can be subtracted. So let's convert that fraction. 90 times 1.4375 is equal to 129.375, our new numerator. And 80 times 1.4375 is equal to 115, our new denominator. Great! Now we've got our replacement, and we are ready to subtract fractions. Let's write down the new representation of our problem. 117 over 115 minus 129.375 over 115. So now all that's left to do is subtract. And the answer is negative 12.375 over 115. Did you get the correct answer? Adding and subtracting fractions can be scary. But when someone actually takes the time to explain it properly, it could be understood by anyone. You've made it to the end of this lesson. I hope that this video has helped you. Thank you for watching Things Explained. Please like, subscribe, and share with your friends.